Alright, so in this video we're going to be discussing arc length. And so arc length is related to the circumference or the outside of the circle. So if I was talking about this whole entire thing, but we're just looking about a specific segment of our circumference. So in this case, we're going to look at like this, for example. And so to get our formula for arc length, that is going to be equal to our circumference, the whole entire circle, which is 2 pi r. And then we are going to be multiplying it by the ratio of our theta, or angle here, which is that, divided by our whole entire circle. And a whole entire circle is 360 degrees. Now, we can also write this in terms of radians. The only thing that's going to switch is our 360. So the 2 pi r will still stay the same. Now, though, it's going to be multiplied by theta over 2 pi. Because again, 2 pi and 360 are the same thing. One is in degrees, one's in radians. So we can also simplify these equations here. So in degrees, I can divide 360 by 2 and simplify that to just leave me with pi r times theta divided by 180. Again, both of these equations are the same. One is just a little bit more simplified. Whichever one works best for you, you should use. And then second, in radians, I see I have a 2 pi outside here being divided by 2 pi. Those two will cancel each other out, which will leave me just with my radius times theta. I would recommend starting with these two and then going and simplifying to get to there, rather than starting with our simplified versions first. So let's go ahead and apply these below. So this question here is asking us to find the length of each arc. So our arc here is this one that's bolded. I'm going to go ahead and just mark everything out. Go ahead and just state what everything is. My radius is going to be equal to 5 feet. And my theta in this case is going to be 60 degrees. Now keep in mind I just said 60 degrees, so we're going to be using the degree version of the formula. So I will have 2 pi r, which is 5, times my theta, which is 60, divided by 360. Now, I'm going to go ahead and just make this the more simplified version of this. So I'll take my 2 and 360 and divide those. So I'll have pi times 5, nothing changed there. And then 60 divided by now 180. So let's go ahead and simplify this even further. I know that 180 and 60 can both be divided by 60. So this can now be rewritten as pi times 5 times 1 over 3. Because 60 divided by 180 simplifies to 1/3. And if I multiply this further, 5 times 1 will give me 5 divided by 3. Don't forget my pi. 5 pi divided by 3. So that would be my answer here. Also, you want to keep in mind your unit. This is also in feet. So 5 pi over 3 feet. If I want to do this in radians, I'm going to go ahead and convert 60 degrees to radians. I'll do that in blue. And to convert that, I would just do 60 times pi over 180, which gives me 1/3, or pi over 3. 1/3 pi over 3. Then I'll go ahead and plug that into my formula, which again is pi r, or 2 pi r times theta over 2 pi. And if I simplify that further again by canceling out my 2 pi's, I'll just have r times theta. So I'm just going to be multiplying 5 by pi over 3. 5 times pi over 3 will give me 5 pi over 3, which is the same answer we got with degrees. So whether or not we have degrees or radians, or if we convert it, we'll still get the same answer in the end, 5 pi over 3 feet.